So today we are going to talk about the Covid X-ray classification problem. X-ray classification. So the objective is to understand that we have some images available on Kaggle.com, and if you will search for here, let us go inside the dataset and let's start searching the data. So there is one popular data here of the COVID X-ray images. So we just starting with the CNN. That's why we are taking this data right now. So that's a generic data to understand how CNN will be implemented on our data set. So let us search for COVID-19, and there is a radiography COVID-19 radiography dataset. So this is the dataset we have. This is what we want. Let's see, this data is of 816 MB. Okay. And these are the chest X-ray images and lung mask database. So let us look into the data we have. So it is giving you these folders like COVID, lung capacity, normal, viral pneumonia. So these are the kind of folders. In these folders, we'll be having the images. After that, we also have one Excel file available. From that Excel file, it will give you the path of the files with some coordinates might be, or some XY, whatever. What exactly we need is the images. Okay, we just need the images. So how we are going to fetch the data from Kaggle.com? First thing. Second thing, how we are going to load these images into our Google Colab notebook. So these are the two things that we have to focus on. After that, we'll be able to build the model. So how we are going to connect the Kaggle with our Google Colab so that we don't have to download the data. Okay, so it's a very like good thing for you to understand that you don't have to download the data set if you are getting the data from specifically from Kaggle.com or GitHub. So all they provide some linking with the Google Colab. So how we are going to connect? So first of all, you need to import the OS package. Then we need to write here os dot environment square bracket Kaggle underscore username is equals to something we'll put here. Okay. So basically here you have to put your username. So my username is Brain Mentors. Then I have to write one more thing. Environ environ stands for obviously environment. Kaggle underscore key is equals to now. This is what we have to fetch from Kaggle.com. So how we are going to fetch? Simply let's go to this icon, that is your account icon here. Let's click on this and let's visit to this account section. Scroll down and you will see one this section, API section here. So here we can see it is asking you to create new API token. Okay, so let's click on this create new API token and it will download one JSON file for you. Okay, so let us open this file. And in this file, you will see this key available and also your username. Okay, so you can just copy the username from here. I know already my username, so you can copy the key from here. Let's copy this key and paste here. So this was the step number one, to connect the Google Colab with your Kaggle account. So I hope we are clear till here. After that, we have to start downloading the data. Now how we are going to download the data? We'll simply write exclamation mark Kaggle space datasets download. Then you have to write, just copy this URL, and after datasets just copy this username till the end. So I'll paste this thing here. Okay, so if you look into this thing again, so I have written Kaggle datasets download, then the username, and the actually you just have to copy this thing from the URL. So this is how the dataset is downloaded from Kaggle.com. Okay, so let me just execute this. It will start downloading this data. So the downloading part is started, and look at the speed it will give you. Okay, so it is too fast to download. Okay, so if you're having like 1 GB, 2 GB, 3 GB of data, it will download in 3 to 4 seconds only. Now let's look in the left. So here it is a zip folder you will get. So if you download the data from Kaggle.com, you will get this zip folder available. Now what we have to do with this zip, you have to obviously unzip this folder. So I'll write here exclamation mark, unzip, then you need to write the folder name, that is COVID, enter, and execute. So it will start unzipping the images now. Just look at this. It is now extracting the images from that zip folder. So this is the part number one. This is the first part, that how to get the data from Kaggle.com. So this is how we fetch the data from Kaggle. Okay, the zipping part is also completed. And now here we have a folder known as COVID-19 radiographic dataset. So all the folders are available. So we can see here COVID images and mask. So today, first we'll be just talking about on images, that how we are going to classify the images. Okay. Then obviously you have some other data sets like viral pneumonia is there, lung opacity is there. So different data sets we have available in this one single one. So what I'll be doing, I'll be simply classifying the normal. So these are the normal images here, versus you can either choose the viral pneumonia or you can choose the COVID, or later on you can choose all of them, like normal versus viral pneumonia versus COVID. Right now we'll be taking two of them. One is the normal and second one could be the COVID, or second one could be the viral pneumonia. So we'll be taking the COVID. Okay, so we'll be classifying based on X-ray images whether a person is having COVID or not. So now we have to just look into the data. Okay, so this is the another important part that we are going to talk about. Like whatever data we have extracted from here, we just want to know how many images we have, how images look like, and all about these things. Okay, so you just need to write here os dot list dir, and then pass the name of folder in which you want to get into. So I'll press control space to get the hint, and then slash, I want to go inside COVID folder, and just put this thing in len. That will give you the length of this folder. So right now you can see two. Why? Because there is one folder images and then there is a folder known as mask. So we have two folder. So let us talk about one, or you can even do one thing. If you click on first image, it will open this image on the right side for you. Let me show it to you. So if I click on this image, it is opening this image here, so you can see how the X-ray images look like. And if I open some images that are mask image, I also don't know what is inside this mask image because this is also new. Earlier it was having only the COVID images. Let me see. Okay, so this is the mask image here we can use. Okay, but right now we just we'll be talking about first images only. So let's get into the images folder here. So we have images, and then length is 3616. Okay, so here the length is 3616. It means in total you have 3616 images of COVID only. Now, how many normal images we have? Let's see. The length of os dot list dir. Then I'll write here COVID 19 radiography dataset, then normal, then I think it also contains the images and masks. So images. Now let's look into the length of normal images. So normal images are 10,000. So this is another problem that we have detected here. So what is the problem here? The training data is not balanced. Okay, training data is not balanced right now, if you will see. So the things to learn in this case study will be that how we are going to balance the data, because COVID images are just 3616 and the normal images are 10,192. So that might not give you the correct or the good accuracy to work with. So I hope you all are understanding my point here, that right now the COVID images are this number and the normal images are this. So data is not balanced properly. We'll be understanding how to balance this data. What are the strategies to balance your data? Because this will happen a lot with you. So in today's session, we are understanding a proper implementation of a project, that how we implement the CNN. But before implementing CNN, you might be facing these problems. These problems are very common. The data is not properly available to you, some mismatching things, there could be a lot of problems. Now the next thing we are going to do is to just let us read one image using OpenCV. I'm just going to read any one image. So I'll just write cv2.imread, and in this imread we need to pass, let's pass only one image, normal, either normal or you, okay, let's plot the normal image, not the data. I just want a normal image. So normal slash, in this normal folder, we have images folder. And in the images folder, we have one image. Let us pick the name of image from here. What are the name of images? Okay, so you can pick any one of the images. Just pick any one of them. Okay, so I'll execute this line. Now in my img variable, I have this image available. And obviously, if you want to plot this image, so you might need cv2 underscore imshow. This is the first choice. Second choice, instead of using cv2 imshow, we can plot this image using matplotlib. So I'll use matplotlib dot pyplot as plt and then plt dot imshow the image. So this is the image. And what is the dimension of this image? Just look at this, 299 by 299 by 3. This is the dimension of this image. And we have to understand one more thing, that whether we are having the same dimension of all the images or they all are of different. So it might be written somewhere here. So this research, okay, so you can also learn about from where it is getting the data. Have compiled this exam which consists of this number of chest X-ray images, which includes 11,000. Okay, okay, so it is, I think, counting the mask and non-mask images, both of them. Okay, so is it giving me the dimension of the images, that whether we have the same dimensions? Yeah, I think here. So all the images are PNG and resolution are 299 by 29. So that's a good thing. Why this is a good thing? Because you don't have to resize the images then, because it is, they are already being resized in, and all images contain the same size, 299 by 299 pixels. Okay, so that's a plus point for us. We don't have to look into that. All right. So after that, we just have plotted one of the image. Now you can try any other image, COVID and all. So we'll be plotting them. But let us first talk about that how we are going to load all these images to get started with the training part. So obviously, if we talk about that, when do we have the data set, we need one training variable. That particular training variable will contain all the images of training data, normal plus COVID. And in my testing variable, I'll be having all the testing data available. So this is what I want. Okay. Now the thing is that we have to load all the images available in my images folder. We have to load all these images. So I'll create one folder here. Let us name it as load images, because I need to execute this for the normal images and as well as the same code for COVID or pneumonia images. So let us write load images and I'll pass a path here, like either of the COVID or of the normal. So I'll be taking one variable here. Let's take one variable images, that's a list, and labels corresponding to that particular image. Okay, so here I am taking two variables. One is the images, that is a list, and another one is the labels that will contain the label, like either it is a normal image or it's a COVID image. So how we are going to work on it? We'll start with one variable, I think. And also you can do one more thing. You can even pass the label from here. So I can write here target. Okay, now what target means, like when you'll be calling this load images function, you can pass either this is the pneumonia image, or this is a normal image, or this is the COVID image. So in that target, I can pass 0, 1 or 2. Okay, so now we have images variable, we have labels variable, and let us start iterating over this for I in range length of URLs. What I'll do in this uh, metadata.xlsx, or let's say, yeah, in this COVID metadata.xlsx, let's do one more thing here. What if I import pandas as pd dot read excel? So I'm just testing what is inside the COVID metadata excel file. So let's write here COVID, then this excel file. Let's open this one first. Covid dot this. So let's write a data frame variable. We have this df variable. Now I just want to check the head, the first 5 observation. Okay, so here we have the URL of each and every image. See, you have the URL of each and every image. So if you want, so you can also use this file for your purpose. And if you don't want to use this file, so that's again okay for us, not a problem, because what I'll be doing is inside the path variable, I'll pass all the images one by I'll fetch all the images one by one. So instead of using this loop, I'll write here for root comma folder comma files in os.walk into the path. Okay, so this is the first way that you can use os.walk and mention your path. So what it will do will give you the root directory, the folder and the files one by one. Or let me tell you the alternatives. So this is the first way, or the second one, we can directly get the path of each and every image. How we can get the path of each and every image? Let me show you then. If you will write here os dot list dir, then pass the COVID dataset, the COVID folder, then images folder. That's it. If you will execute this line, it will just return the name of each and every file available in your directory. Okay. So here we have the name. Okay, just the name, not the full path. So how you will get the full path? You just need to concat this thing. You just need to concat this thing here. Okay. So that is just to show you that how you can read the images path. Okay. Now, what I'll be doing is in path variable, it might be a list. Your path variable could be a list that contains all the URLs of these images, or you can use these URLs one by one. It depends on you, whichever way you want to prefer. Okay. So let me choose one of them. So I'll write here for I in range, length of path, and let's write one more thing here that I want to write here cv2.im read the images one by one. So how we are going to read the images one by one? You are going to pass the path of I, but it is not going to read the image directly. Why? Because what do we have inside path of I? The name of image, but you need to provide the full path just like this. You need to provide the path like we did here. So we also need this thing. Okay, I hope you are getting this thing. So what I'll be doing is I need to pass the URLs as well. Okay, so now instead of writing path like this, let me show you what I'll be doing. I'll write inside the path variable, we'll put this. Then from the URLs of zero index, I'll just append it with the URLs at zeroth index. What do we having in the URLs? We'll be having this thing. URLs is a list which contain the name of images. So first I get these URLs. Now what I have in my URLs variable is the name of images. Then what I'll be having in my path variable is the full path to that image. This is what it will become. Now it becomes easy for me. So I can write here that image underscore path is equals to, so image underscore path is equals to, we'll write here the path plus URLs square bracket I, and it will start reading the images one by one. So now in img path variable, I'll be having one image path at a time. So this is the kind of thing you will be getting in your img path variable. I hope you are able to understand this thing. Now that we have the image path variable which contains the path of each and every single image, so let's read using OpenCV. And why to use OpenCV? just to get the pixel array of it. So you'll get the image finally here. Now I in my img variable, I have the image available and I don't have to resize it because it is already 299 by 299. I'll store the images one by one. So I just need to put here. So what are features? Features means the images. Feature means the images I am talking about. Okay. So in my images variable is a list. So this particular list contains the images one by one. So it is storing one by one. And in my labels variable, I'll keep on appending the target that you're going to pass. And finally, I'm going to return both these things, labels and the, so first I think I should write the images. The second thing we need is labels, and that's it. So this is my load images function. How it is going to load the images, just look into it. So first I need the COVID path. So let's take one variable COVID path, and in COVID path, just copy this thing till here only and paste. Okay. So this is the COVID path. Then I have the COVID URLs is equals to copy this line and paste. Okay. So first I have the COVID path variable, which contains the path of COVID images. Then I have COVID URL variable, which contains the name of each and every image available inside the COVID. And now finally I can call load images function. In that I need to pass two things. One is the COVID path. One is the COVID path. Second is the COVID URL. And in return, and also you need to pass the target. Target is what? Target is either 0 or 1. So here I'm passing 1. 1 means you are infected with the COVID. This particular X-ray image is of COVID. So let's put it in a variable. So I'll be having two variables. One variable name is COVID images. Second is the COVID targets. And execute. So finally, it has loaded all the COVID images, and there is one last thing we have to do because images variable was a list. So if images variable was a list, then if images variable was a list, so you cannot use it as an array. So you need to typecast your variable. So you need to typecast your variable into array. Why we need to do that? Because the Python list cannot be used for a lot of purpose, like you cannot directly reshape the data, you cannot divide the data by 255 to normalize the images. A lot of things are there. So that's why I need to convert this data into numpy array. So I'll import numpy as np. Okay, and what if in case the dimension of image is different? What you have to do is just need to write cv2 dot resize the image, and now you have to take one common dimension. So just understand this thing. So if all the images was of different size, I want to resize them into 100 by 100. So this is what I'll write here. This is how my images will be resized. If we want to resize the images. Okay, so this is how we are going to resize. All right, so let's get back here and we are going to write np dot as array. Actually, I'll convert them in later. First, let me load the COVID and the normal, both of them. So first we have normal path. In this normal path variable, I'll copy this and paste here. Instead of COVID, we just have to write one thing, that is normal. So you'll have the normal images. Then we need a normal URLs is equals to os.list_dir. And in fact, let's make it a little bit more short. You don't have to write the whole thing. You just need to write COVID path here. That makes it more easier to write. And there you need to pass the normal path. And that's it. And finally, you'll be having the normal images. comma normal targets is equals to load images, pass the normal path, and second thing we need to pass is the normal URLs. Third thing we need to pass is 0 for the normal. So just execute and that's it. It has loaded all the images. See how fast it is doing all these things. Okay. So it has just loaded all the COVID images, target images, whatever we have. Now we need to convert this into the NumPy array. Okay, why we need to convert it into NumPy array? As I told you, because a list cannot be used to find the shape of data. There are a lot of things we won't be having. So that's why I'm going to convert my data first into the array. So we have np dot as array. You just need to pass the COVID images and the normal images. So COVID images will be updated here, and the normal images will be updated as well. Now my COVID images and normal images are typecasted into, let's name it as normal images, are being typecasted into the NumPy array. Why I did this thing? So now I can see the COVID images dot shape, because a list will not return you the shape of the data. Okay, there is something wrong with our code here. There is something wrong with our code, and what is that? Let's see. There is something invalid. I just need to check the length of each and everything. So let us check the COVID URL variable. What is the length of this variable? 3616. So loop. Okay. So this is the thing here. Just look at this. What mistake we did? We have written path here. And what is the length of path? This is the length of path. So that's why it has loaded 41 images only. So it means 41 characters are there. So this was the mistake. So instead of path, it must be URL. So that's why I was wondering it was too fast to load the images. Now execute again. It will take a little bit of time in case of the normal one. And also check the length of COVID images to make sure that it has loaded this number of images. Yep, perfect. Now let's execute the normal one. Check the shape of COVID data. Now there is one more problem, that it is returning just the shape of data. It is not returning the dimension of the images. So it should return like what is the shape of your data, as well as it should return the number of rows and the number of columns, the dimension of data properly. So I need to check on 0th index what I have. Something is still invalid in the code. Image path is equals to path plus URLs of I. Then we are reading the image. I'm appending it here, labels this. What could be the possible problem? Let us see what do we have on 0th index then. Nothing. On 0th index, we have nothing here. Something is mistaken either here. Let's print the image variable then and see what is the problem going on here. Let's see. I think we should print the path only. Then let me check. Okay, so there is one slash is missing. Just look at this. The slash is missing from here. So you just need to write plus slash plus. Now it is perfect. So it should be with a slash sign. Now I think that should work. Let us execute again. So these are the basic problems you will definitely face. Okay, now it is taking time. So it means this time it is going to fetch all the images properly. Okay, let's see for the normal one. Then after the execution of this, we'll convert it into the array again. So, okay, so it is executed. Let's convert them into the NumPy array. Okay. Okay, now after that, let's see the shape. It must be 3616 by 299 by 299. If all the images are having the same dimension, then always expect that first it is going to return you the shape of the data, that is the how many number of images you have. Then second and third thing will be the number of rows and number of column, and fourth thing might be the color channel if it contains one color channel like 3. So if in case of RGB images, it is taking too much time. Okay, now just look at this. Okay, perfect. Similarly, I have a normal images and I can check the shape of it. So it will return 3616 by normal images. 3616 by whatever the number of normal images we have, then the dimension. Now the data is perfect. The data is perfectly available here. So you have COVID images and normal images, but they both are in a separate variable. The normal and the COVID images both are in a separate variable. They should not be in a separate variable. They both should be in one single variable. Okay, there must be one single variable known as images, and that images variable must be having the normal plus COVID images. Both the images must be contained in one single variable. So how we'll get this one single variable? We can do one thing. As you can see, we have converted all the things into array. Now NumPy has a very simple way, r underscore. Okay, what is this r underscore? It is basically to stack the data row wise. See, first of all, let's look into the problem. The problem is I need one variable, that is data, or let's say I want a variable known as xtrain. The xtrain variable should contain COVID plus normal images. Both the images must be in my one single variable. So I need to concatenate the data row wise. So NumPy has a r underscore method. So here I can try the COVID images first here and then the normal images I have. These two variables I am using. And then let's put it in a variable known as data. And after concatenation, I'll test the shape. It must be 10192 plus 3616. I hope that is clear to you. That now data variable contains 3616 COVID images and 10192 normal images. So I just have stacked the images. Obviously, that's not a very good practice because the first few images are of COVID, then few images are of normal. So obviously, when you will use the train test split, it will shuffle the data. So that's not a problem right now. The same thing you need to do for this target variable. So what you have to do, you just need to write targets is equals to np dot r underscore. So first I need to put the COVID targets. Then I'll put the normal targets. Okay. What I have in my COVID targets variable? In COVID targets variable, you'll be having 3616 length and it contains only 1. In normal targets, you have 0. How many zeros you have? 10192. And execute and let's see the shape of target variable. Perfect. So now finally I have the whole collection of data. So that is the perfect data. Now the data is being completely like being ready to pass into the train test split or whatever processing you want to do. I have one data variable. In this single variable, I have 13,808 images. Out of them, 10,192 are normal, 3616 are COVID images. Finally, I am ready to divide my training and testing data into training and testing part. But this was the first phase. Whenever you are fetching the data from somewhere, that you have to convert your data into one single variable data, and then you can pass it in your train test split method. All right, so now we have converted all the things. The next thing we are going to do is data is equals to data divided by 255.0. Just to normalize your data, because at the end you have to normalize the images. So now I will execute this line to divide my data by 255 that will normalize my images. But now there is one more problem we are going to face. Look at this at the top right. Just look at this. It has failed. Actually, the problem was the RAM was completely occupied. So you can just look at this here. Your session crashed after using all available RAM if you're interested in access. So this is one of the problem you'll be facing in Google Colab. Okay, so just look at this problem. What exactly the problem is? We have this data set and available, and if you just look into the size, it becomes a huge array. After that, it gets failed to load all the data in this amount of RAM. So I think by default we get 12 GB of RAM, so it get exhaust in 12 GB of RAM after this data. So what I'll be doing is, first of all, I think let us execute. We have to execute few things again, not the download part. The data is already with us. I'm going to execute these cells again, and I'm going to do few changes. Okay, I'm just gonna do few changes. So before returning, like if I'm calling this load images function, I will directly do one thing here, that I will divide my image by 255 directly here, so that later I won't be performing the operation on the images. The first thing here I did here, this thing. And before returning the image, I will convert them into array directly here. Okay, so there are few changes that I'm doing right now. The first change is that here I am dividing the image directly with 255, and then converting, before returning the images, I'm converting them into the numpy array. So why I'm doing this? Because at the end, I won't have to perform all these operations. Okay, this is why I'm doing this thing in this function. Let's see what we'll get. And we have to keep track of the RAM, that it should not get exhausted. This is one of the problem we face while working with the data of images. And just look at this, it is already occupied this amount, 4 GB of RAM, and still we have to load the normal images. Okay, so it is again crashed. I think I need to restart. I think we should restart this. And let's connect. So in case if we are getting again and again this failure कि बार बार ये जाकर fail हो जाता है हम लोगों का कि it is showing you the RAM is completely occupied and all. So what we can do is we can change our runtime type. So let's pick the change runtime type from here and just choose GPU and then try. Okay. So we'll execute the whole code again and then see if we are able to execute this code now. Okay, so it is unzipping the data now. Okay, so it is successfully unzipped the data. Now all the steps will be same. We don't have to do anything. Just execute the code. Keep on executing it and see if we are able to get this code. Because the problem with GPU is also that it generally works when we have to train the model, because we can see still RAM is getting exhausted here. And just this code. So instead of going this into this again and again, let us simply download the data and directly execute it using the Jupyter notebook. So I'm downloading it from here, save it. Okay, so it will take few seconds to download this data. So let us simply download this file and save here. And from my directory, I'll cut these two things, start the Jupyter notebook I'll put both of them in a new directory, CNN implementation, paste here. Now extract the data here, and after that each and everything will be same. We don't have to change anything else. So let us open the implementation folder. Here we have this code, and let's see if still it is fetching the data. So now you don't need this code, the first line, second line. So if you want to execute the same code, so I just need to import the packages here. So let's move it. Here I need to import OS only. Okay, and let's wait for it to unzip the data. Okay, now each and everything will be same. I'm not gonna do any changes. Just look at this. I'm executing all the things as it is. Okay, now let's try to execute this code. Obviously it will take time here. It is gonna take some time here. So if we are getting this memory error because we have this number of images available, 3616, and then one is 10192, and then we have the dimension as 299 by 299 by 3. And if we look into this, so it becomes like 299 into 299 into 3. These are the parameter for one single image. Okay, these are the number of feature for one single image we have. So that's why it is like exhausting memory after certain amount of time. There is one more alternative we have. Actually there is one more solution we have, but for that, to get started with this solution, the first solution is obviously we can resize the image. Okay, the first solution we can try is the resizing the image. Second solution that I have is to use keras. Using keras, it can fetch the data in batches. You don't have to do anything from your side. You don't even have to write code for anything. We just need to use the keras. But first, I'll show you how to use some resizing thing. Let's say I just want to resize the images that I want to use. Then I will train. Then I will load this data again. So this time it might help you out for this part. But parallelly, I will tell you how you can use the keras. But before using the keras, there's one basic prerequisite, that your data must be having a proper directory structure, and the directory structure must be like this is a folder. Then inside this directory you should be only having two folders. Okay, two or three, whatever the folders you want. Like you should remove all these files must not be inside this folder. So there must be COVID folder and normal folder only, first of all. So after that, inside these folder you will be having images directly, but here we have images and mask, two directories. So first we will have to convert all these things into the proper directory structure that I will tell you obviously. But now let's execute for this one and see if it is able to convert the normal images now. You can also do the same thing here, that instead of executing the whole code with the same dimension, just resize the image into 100 by 100, and then you can try on. Okay, so we just have resized, and let me execute from this line. I'm trying it parallelly just to make sure that if collab is working fine with that. Okay, so now the normal images are also loaded successfully. So this time it has worked successfully. The only change that I did here is to resize the images into 100 by 100. And after that it is working. Now this is one more step, that it has to like concatenate all the data. Okay, so it is also done. Now finally the data is ready here. Okay, Now we can see data is ready. So now comes the next step, that we are going to divide the data into training and testing. So how we divide? From sklearn dot model selection, import train test split, then use train test split, pass your data, that is data variable, then your targets variable, then the test size, let us say 0.25 I'm passing, x train, y train, sorry, x train, x test, y train, and y test. Now we are going to see one problem as well. Okay, there will be one problem at the end, not right now. At the end, we'll be having one problem of accuracy, because as I told you in starting that the data is not balanced. Okay, either we should have executed the loop only till 3616, so that normal will be also that and the COVID will be also that number of images only. So that is one other thing that we should have tried before going into the before resizing the images, that we can also have tried. So finally we have x train, y train, x test, y test. Now it's time to build the model for us. All right, so now finally we are going to build the TensorFlow model. So we need to import TensorFlow as TF. Then we need from TensorFlow, let me check if I have properly installed TensorFlow here or not. Then I need to write from TensorFlow dot keras dot models. We just need to import the sequential. Okay, the way we are going to build our model will be using the sequential one. Okay, in the sequential one you just pass the layers one by one, stack the layers one by one from your side. Okay, so we are going to use that particular strategy. Then what other packages we need for that? So from TensorFlow dot keras dot layers, now we are going to import some layers. Like there is one layer conv 2D, then we need max pooling 2D, then we need the flatten layer, then we need the dense for the hidden layer. Okay, so we have the convolutional layer, max pooling layer, flatten layer, and the dense layer. So these are the four layers that we need in our model. And what else we need? I think that is sufficient. Okay, so first of all, execute this and start creating the CNN model. So first we need to create the sequential object and put it in a model variable. Okay, so first we need to create the sequential object, put it in a model variable like this. And after get inside this sequential variable, start a list and now start passing your layers. So the very first layer that I want to pass will be my convolutional layer. So I'll simply write conv 2D. In convolutional layer, the first parameter is the number of filters you want to pass. So just get into this. So by default, it asks you to pass the number of filters. Like it is generally in multiple of 2, like 16, 32, 64, something like that. So I'm starting with a basic 32 number. Okay, right now I have no strategy to which number should I pass. So I'm just passing 32 from my side. Then it asks you to filter window size, the kernel size. Like the filter window will be applied of, let us pass here 3 by 3, or you can pass even single 3 if both the dimensions are same. So I can pass 3 here. Now the next parameter is needed here is the input shape you want to pass for the very first layer. So whenever you are using this first layer, you need to pass this input shape as well. Like what is the input shape of your data? So currently my input shape of data I can fetch from the xtrain.shape. Okay, so you just need to pass the image width, height, and the color channel. These are the three things that you need to pass. Okay, so I'll pass here 100 by 100 by 3. Right now I'm just doing this thing as hard coded, but it's not recommended to do hard coded. Just put them in variable, because later on you might need to change the dimension. So later on try to make some variables. Okay, so I'm having this. Then I need one activation function that is recommended to use the ReLU by default, because whenever we build the convolutional layers, ReLU is the activation that we generally use. Why? Because it reduces the negative value, it removes the negative value if it is multiplied with filter or something. Now there are one more padding, then there is one more parameter we can pass, that is padding. So as I told you in the CNN session, that when we talk about the padding, padding is passed when you want to write like either zero, you pass a padding of zero, or you pass nothing. So padding contains either the value of valid or it could be same. Now let me show you the valid parameter, the padding parameter. So either you can pass valid or you can pass same. So valid means no padding. So it means no padding will be applied, and same results in the padding with zeros. It means it will evenly apply the zero padding if you pass the same. So it's up to you whether you want to pass or nothing. So I'm not passing because padding will be valid by default. Okay, later on to perform parameter tuning and all, you can try change the value of padding. So this is the layer number one we have, convolutional 2D. Just after convolutional layer, we have to pass one max pooling 2D layer. Okay, so we need to use this max pooling 2D, and in this you need to pass the pool size. By default we already have the pool size of 2 by 2, so it means there will be a 2 by 2 window that will pick the values automatically, the maximum value out of the particular 2 by 2 window. And then we have strides and padding as well. Strides, like in what will be the stride value of your sliding window, like you want to move 1 pixel at a time or 2 pixel at a time. If you don't want to set anything, you can just keep it as it is. By default it is none. Okay, and there is this formula that goes for your output shape, the input shape minus pool size divided by stride plus 1. That gives you the shape of the output, like what will be the output shape after implementing this layer. Okay, so by default here the value we have is none, that is by default set. Okay, either you can pass a tuple 2 by 2, 3 by 3 or something. So if none, it will default to the pool size, whatever the pool size is, that is 2 by 2. Okay, so if I am saying that pool size is 2 by 2, it means padding is stride is also same. It also move your sliding window by 2 pixel at a time, and if you want to change that, you want 3 1 something, you can change it. Now let's copy these two layers and paste them, and then you can try changing the number of filters like this. Like this time I'm using 16, then again 16, and you don't have to pass input shape again and again. The input shape is passed only once in the very first layer. So now you have 3 convolutional and 3 max pooling layer. So in starting we was having 100 by 100 image that will be passed to convolutional, then apply max pooling, then again convolutional, then max pool, like this. So this is my CNN architecture till here. After the CNN architecture, we have to apply the flatten layer that will create your input layer. This flatten layer is going to create my input layer that will contain all the neurons. So we'll see how many neurons we'll be having in the input layer. We will see that. Now we need to pass the hidden layer. So this hidden layer might contains, let us say, 128 neurons, and activation I'll recommend to use generally here is ReLU again. And now comes the final output layer. Now the output layer will also be the dense one, and how many outputs you have? Only 2. So if you want to use 2 here, then activation will be the softmax. And if you don't want to use 2 here, so let us say you want to use the sigmoid. So if you want to use sigmoid, you can go for it. But then output layer contains only 1 neuron. So that depends how many neurons you want in output layer. So this is how our model will look like, and somewhere I missed this comma. Now let's look into the summary of this model. Let's see what exactly we have built. So first of all, we are going to pass this input and the output shape will be this. Okay. Then the output shape will be of this, then this. So this is how it is going to convert till here. So these first few layers are of convolutional. Then after the convolutional layers implementation, the flattened layer will be this, and it contains 1600 neurons in input layer. In your input layer, you have 1600 neurons. So I think you should increase the hidden layer neurons because you are receiving 1600. So I am taking 512 neurons in the hidden layer. Or you can even change, or you can include one more layer with, let's say, 256 neurons. So I just have introduced this thing because I can see I'm having the 1600 input neurons, then 512 and 256 will be my next two hidden layer. And then finally I have my output layer. So the model is being created successfully till here. Now the next part is to compile the model. So we have model.compile, and in the compile you have to pass the optimizer that we are going to use. Adam is the optimizer. Loss function that you're going to use, tf dot keras dot losses dot, and then you can pass binary cross entropy because I'm having the binary output. Okay, so that's why I'm using the binary cross entropy. And finally, one matrix is here that will contain accuracy, that I want to see the accuracy of my model and execute this. It will compile your model. And now comes the training part. So I'll train the model using model dot fit. Inside the fit method, you have to pass your training data x, y. So I'll pass here x train, y train. This is my training data. Then you have few other parameters like batch size, and also I'll pass a batch size of 32 images by default. Then epochs you want to train, like I'll start with 5 epochs just to see how my training is going. Then you need to pass your validation data, or later on you can validate. In that I'm passing my testing data right now, x test and y test. And what else I need to pass? Okay, so these things are enough as of now, and let's execute this model.fit. So just to make sure the model started the training part, and let's see what accuracy we'll be getting. Right now, I'm not using GPU. Obviously, it will be a little bit slow, but eventually, if you'll use GPU or something, it will start increasing the accuracy, but like it will be fastening your model or do something like that. Okay, so let's see. This is the first epoch going on, and we are going in a good direction of the accuracy, but this is only the training one. The things depends on the testing accuracy because that should be also good. Because as I told you, the data is not balanced, so that might result in overfitting or something. So the problem we might face is the training data accuracy is good, but testing data accuracy is not that good. So that might happen. Okay, but let's see what accuracy we can get. Okay, so just look at this. The training accuracy is 83 and testing is 89. That's a pretty good thing we are getting. So I think the model is getting in, going in a good direction. So now it will keep on training the model and all. So the same thing you can try here as well. Like I just stopped here, but you can keep on executing the same thing here. I'm using the same thing, obviously. So it depends on you whether you want to use the Jupyter notebook or you are good with the Colab. It's up to you. Code is same. Nothing has changed with the code part. So let us wait for this to complete the epochs. Now finally, after training the model, we can see here we are getting the 93% of accuracy. That is pretty good right now. Loss is being decreasing as of now. We can see there is no overfitting in the data, and you can even try to plot it. So I already have imported the matplotlib. So plt dot plot. I'm going to plot the accuracy and the loss. So I just need to write model dot history dot history, then pass the accuracy here, and then plt.show. So this is the training accuracy. Okay, so parallelly I want to plot the validation accuracy, and the label will be, this is my train accuracy, and here the label will be test accuracy. Okay, so this is how it is gonna plot, and then I will write plt.legend. So this is going to be your accuracy plot, and let's plot the same for testing one. So this will plot the loss, then validation loss, then train loss here I'll write, and the testing loss here I'll write. Okay, so finally now you can see the training and testing loss and the accuracy is being plotted, and As I can see from the graph as well, I'm not getting any overfitting or something. So that's a good thing. Let me rename the file with COVID CNN X-ray classification. Okay. So I hope we are clear till here that how to implement one simple model using the CNN. So this is the COVID chest X-ray classification case study that we have completed with a good accuracy and all.